So as you may already know, Python sets will not allow duplicate items. Let me demonstrate. Here I have a list called fruit list that just has 4 strings inside: pear, banana, apple, and apple. Now in Python, we can convert this list into a set by using the set function. So down here, let's say fruit set, and then let's use the set function with the fruit list as our input. Then we'll print our fruit set down here. Okay, so when I run this, you'll notice that our second apple string is now gone. So we all probably expected this to happen because, well, this is just what we've always been taught about sets. They remove duplicates. But why do sets do this, and what's the benefit? Well, before we dive into this, I need to explain hashing. So essentially, hashing is just a way to convert any input data into some number. This number is called a hash value. Basically, if I wanted to get the hash value of some string, I would input that string into a hash function, which would output the hash value that's unique to that input. If you ever wanted to get the hash value for something in Python, all you have to do is use the hash function. So let me demonstrate. Let's get the hash values for each of these strings in our fruit list. Let's delete this set here, and let's copy fruit list down here and call it fruit hash vals. Then in here, let's run each of these strings through Python's hash function. And then let's print fruit hash vals down here. So when I run this, you'll see that we now have the hash value for pear, banana, apple, and apple. You'll see here that these 2 apple strings have the same hash value. That's because the hash function is consistent within any particular run session. Anytime I input apple into the hash function, I will always get the same hash value. Now, note that I said within any particular run session. What I mean by that is when I run this script again and start a new run session, these hash values will be different. So let's run this, and you'll see that they're now different. The reason for this is that Python uses a randomized seed in the hash function for each run session. This was implemented for security reasons so that the hash values are unpredictable. Okay, now that I've explained the concept of hashing, let me now show you this quick analogy using dictionaries to help understand how Python stores items in sets. Okay, so here I have a dictionary called fruitdict. At key 1, I have pear. At key 2, I have banana. And at key 3, I have apple. Okay, so if I wanted to access apple, I would say fruitdict at key 3, and then I would get the apple string. This has a lookup time of big O1, meaning no matter how large this dictionary gets, if I provide the key 3, it would instantly return our apple string. However, this requires prior knowledge. You'd have to know that key 3 contains the apple string. Okay, well, what if instead of storing these strings with some key like 1, 2, or 3, let's instead store them as the hash value of these strings. So at hash pear, we store pear. At hash banana, we store banana. And at hash apple, we store apple. Now, if I want to get the apple string from this dictionary, its key is easy to calculate. All we need to do is get the hash value for the apple string, and that's the key. So if we do fruitdict with a key of hash apple, it's able to instantly find our apple string. So this is essentially what a set is doing in the background. This is what's known as a hash table. Now, of course, when you see a set, it doesn't look like this. You only see the values stored here. You don't see the keys because there's really no need to display them. The keys are just the hash of these values. Okay, now say I want to add another apple string to this hash table. Well, where would it be stored? Well, it would be stored at the key hash apple, which already exists, and it already contains our apple string. So there's no need for Python to add it again. In a hash table, you can't have 2 identical keys. So this is where Python removes duplicates in a set. So when I run this, you'll see that we only get 1 apple string. Okay, so what's the benefit of all of this? Why are sets stored this way? Well, the benefit is lookup speed. If you wanted to check whether an item exists in a set, Python simply hashes the item to get its unique key and checks the hash table using that key and instantly returns a value, no matter how large the set is. Comparing this process to a list, however, Python would have to go through each item one by one, which can be time-consuming for longer lists. So hopefully that gave you some helpful insight of what's going on behind the scenes in Python sets. If you liked this video, be sure to leave a like to let the algorithm know it should recommend it to more people. If you like how I teach things, be sure to subscribe for future videos and consider checking out some of my previous content. Thanks for watching, and I'll see you all in my next video.